supervised. Under the supervised, there are a lot of files, but you look for this file. I have added some new information to the latest Python file. So you download the whole folder. So inside that folder, there are 3 files. I believe there are 1 Python file and 2 data set. Okay, so there will be 3 files under my folder.
Sir, you want to see how sad my post is? No, literally no one respond from August 2nd.
Why no response?
I also don't know why. I shared in your group, in your classroom.
Student. So can you feel how sad am I if those students respond my post or my class?
No,
This is how you feel.
I can almost feel how sad you feel when you see me sleep.
Yeah, like being seen by girlfriend or boyfriend, being seen by like something the same feeling lah. Never mind, it's okay. You can delete the post already.
Okay.
You can delete the post, because we already decided the 1st of September.
Okay.
I'm not yet decided lah, not finalized yet, but tentative. Okay, so give me another 2 minutes, 2 minutes, then I have to start the
The
class.
midterm and the exam, we won't be asked to write Python code, right?
Depend my moods lah. If my mood is very bad then I don't. No lah, there will be no Python code in the midterms. Yeah. Maybe next semester I will consider, so that our students will pay attention.
For the practical.
Okay. Last week we have covered several machine learning use cases. If you still remember, we have covered a simple machine learning to predict a gender using name. You still remember? And then the second case, we predict the polarity of a word. For example, whether it's a positive or whether it's a negative, based on so-called training data set here. So in these practicals, we're going to learn more machine learning algorithms and discover more about machine learning. What is the pipelines? What are the types of machine learning? And what is the proper procedure to train the models and so on and so forth, right? Okay, so in this practical, there are actually 4 cases. There are 4 examples. But unfortunately, I think I can manage only show you 2, which is using linear regressions. And others, I'm going to use logistic regressions. Okay, so before we move into the examples here, so I would like to explain a little bit first what is machine learning. Okay, so machine learning here is actually a subset to AI. Okay, is a subset to AI. Mainly the aim, the purpose, the aim for the machine learning is to teach the machine. Okay, teach the machines to find the patterns. Okay, mainly to teach the machine to discover or to find the pattern. This is very important between the features and also the label. So this is I will treat it as X. So this is Y here. So that's the main purpose for machine learning, is to teach the machine so that they can learn or they can find, discover, or find the underlying patterns between X and Y. Not X and Y, it's actually between inside the data. Inside the data first. Okay, so this one later. Okay, mainly to teach the machine to discover the pattern inside the data. So under the machine learning, there are 2 types of machine learning. The first one is called supervised machine learning. It means that you need someone to supervise the model, the algorithm, during the learning process. It's called supervised. There's another type of machine learning called unsupervised machine learning. This is called unsupervised. So unsupervised here we will keep it for next week. Okay, so this one next week. So today we will focus on supervised machine learning. So what is supervised machine learning? What is the purpose? It's mainly to predict or to classify the object. Okay, mainly to predict. So for supervised machine learning, there are two types of prediction. The first one is based on the continuous value. Okay. The second one is class. There will be two different so-called data type in your maybe the data. If your data is in continuous value, then you have to use the correct algorithm to train the model. For example, continuous value, normally we use linear regression. For class, what is class? For example, true, false. You want to predict whether it's a male, it's a female. You want to predict whether it's a spam or not a spam. It's called class. If you want to predict this kind of class here, then you cannot use linear regressions. Maybe you can use logistic regressions. You can use a support vector machine. Last week we learned about naive Bayes and so on. Okay, so in order to find the underlying pattern for supervised machine learning, you need these two data. Okay, so unsupervised next week. Okay, so if you want to train the models about supervised machine learning, you need these two information. You need features and you need label. Okay, if the data set, the nature of the data set is in continuous value, then you have to use linear regressions. Else, you have to use logistic regressions, naive Bayes or support vector machine. So in the first example here, you will scroll down, you should be able to see the process flow for supervised machine learning, which I already covered last week, how to build a single algorithm to predict the gender. You need a data set. From the data set, you extract the features and the label. Then you extract the features. For example, the first letter. The first letter is, let's say, is A, is a male. If the second letter is AA, is a male. So that is the feature extraction. So you extract the features, then only we train the model. Okay, we train the model, done. We need to assess the model, assess the performance of the model. Is everything okay? Like above 75%, 50%, we launch to the market for the prediction. So that is the overall flow. Don't worry if you cannot get the picture of this. We go through the case here. So in this first case here, I'm going to predict the house price based on the square feet of the room. Okay. So in the first case, I'm not going to use any data set from Kagan, or I'm not going to use any data set from NLTK, for example. I will like to treat my own data set in this example. Okay, look at the step 1 here. Okay, so you will see that I have a few parameters. Okay, so this one house size, I will treat it as my features, X. Okay, I will treat this house size as my features, and I have to treat the Y here is price, the cost of the house. Okay, so I have two parameters. Remember, this is supervised machine learning. We need these two parameters, X and Y. So in the first case, I will treat the size as my features, and I will treat the price as my label. Okay, so this one later on you can modify. Okay, you can. In this case, I will just treat 10 data. You want to treat 20, 30, well, that is up to you. But in this case, I will just use 10 data. Okay, so what's the next? So, in order to give you a better visualization, I try to use NumPy to plot the graph here. So, from this graph, then you will know that the house size is actually having a linear relationship with the price. Means that if the house size is bigger, the price is also bigger. It means it is also expensive, getting expensive. So my objective, okay, I would like to build a machine learning model so that if in future I have a house size which is not seen by my data set, let's say it's like 1,200 square feet, I want these models to predict what will be the cost. If let's say the house size is about 1,200 square feet. Okay, so that is my objective. Clear? Clear? So look at this overall process flow. Step 1, prepare the data set. This is my data set. Identify which one is your X, which one is your Y. This is very important. Okay? Step 2, identify the features and also extract the features. But I don't think you need to extract the feature for this case because it's understood that the house size is for the features. You straight away use the house size as your X. Okay? So the purpose I reset here is I want to convert the row into a vertical form, into this form. So this is a standard format that required by the machine learning model. Alright, so this is the step number 2. Once you have an X and Y here, then the next step you split the data. If you still remember last week we talked about 70, 30, 80, 20. So this is the standard procedure to split the data in supervised machine learning to avoid overfitting from happening. So after you split the data to 80, in this case I split the 80-20, that means that 20% assigned to the test data and also the 80% to the training data. So I split the data, next thing I can straight away fit the model. So since the data is a continuous data, then I apply linear regression. So you can see that I apply linear regression. I apply the linear regression and I start to fit. Fit means I train. I train the models using this data, X and Y. So remember just now I have a 10 data here. So I split 80%, 20% means that 8 data I will fit into the training process. Okay, and then the remaining 2 I use it for testing purpose. So from here, okay, I will X train, Y train, start to train the model. I need X and Y. So this is the house size, this is the house price. So once done, then I will start to predict. Okay, I will use this remaining 2 here to put it here, put into the machine learning models, and let the machine learning to do the prediction. So after I have a prediction here, then I can actually compare the actual Y. So I have a predicted Y. I have an actual Y. Then I can actually compare and to measure the performance, whether this model is good or not, whether the predicted value is far or close to the actual value. All right. So did this taste okay? Okay. Or double A. Not with me. Where are you? Are you still with me or not? Huh? Okay. I think 30% with me, like 80% don't know where. like the machine learning model. Okay. So should I continue? Yes, okay. So I would like to explain first, because for the coding is not really difficult to code. You can even get the source codes from the internet. But the most problem is you have to understand the concept, idea behind this. Only you can customize your own machine learning models. You can customize your own data sets, customize the parameters of your model. Alright, so okay, if you don't understand the coding, it's okay. Let me show you what is happening from this code. Do you still remember in your secondary school, you have this kind of graph, X and Y? Yeah. So this is X, this is Y. So X here is the house size. So Y here is the price. So let's say now you have a 10 data. You gather the data. Okay, if 500 square feet, what is the price? Okay, this price, okay. Okay. So from this data, you can actually best fit the graph. You know what is best fit? Best fit means that you're going to use some algorithms to draw a line so that the line is very close to each of these points here. Okay, maybe you use linear regressions. Maybe this is the best line that will be given to you. Where this line is very close to this point, this line is very close to this point. So there will be another line here, but linear regression will find the best line for you. The line that is very close to each of these theta is called best fit line. This is what you learn in a secondary school. Huh? Okay, so once you get this line, what is the purpose? You can generate equation. This is linear equation. Remember? How to get the m? Gradient. How to get m? Is it y divided by x, right? Then you get the gradient. The difference between y divided by difference between x, then you get the gradient. Okay, so how to get the c? Yes, very good. This is y intersection point. So once you get the gradient and c, then you get this equation. If let's say I will assume that m is equal to 0.3, then you get x. C is equal to maybe 100k. Okay, 100k. Get this equation. What is the purpose for this equation? Have you ever think what is the purpose for this equation? Or you just simply, equation done, and you submit to your lecture and done. So this equation is very important where you can actually do prediction. Given that if the x is equal to 1,200 square feet, you just substitute this 1,002 here. Then you will get the predicted y. So in fact, you already learned machine learning during your secondary school. Yeah, true. This is the machine. This is one of the machine learning technique called linear regression. We assume that the data is linearly correlated. Okay, why we need to get the equation? So that we want to predict the y. We want to predict the y. Okay, so you can see that it's all of the algorithm that you see 9 biases support vector machine linear regression here actually supported by the equation. If you can understand the concept behind, then you can actually understand the whole practical already. You can understand how machine learning works. It's actually where we use the data set to generate some models or some equations. And these equations help us to do the prediction based on the input value. Okay? Yes. So that, alright, so it's actually the same, right? So the moment that you prepare the data set, you fit the models. The moment that you fit the models, if you generate this equation for you, and you have the equation, then you can predict or put the x into that equation, it will give you the predicted y. So now, my question is, let's say now, we know that this line here, this line is actually called model. This is your machine learning model. It used to predict the y value. So how to know that whether this model is a good model? We need to compare the actual and also the predicted y. So how to compare? It's very simple. You just take one of the, I just take one of the example, let's say this case, this point. Okay, so we know that this coordinate is somewhere around here. We know that this is x and y here. So let's say this is 10, this is 20, if let's say a coordinate. So this is the actual x and actual y. So this, use the same x data here, we will get the predicted y. This is predicted y. So let's say now, I assume that the coordinate for this point is 10. This is about 25. Assume. Then based on these two coordinates, we can actually find the error between these two data. It's called square error, where we have the predict y, which is, let's say, 25. So this is actual. Actual, we have 20. So what is the square error? Square error will be 25 minus 20 squared. So you will get 25. So this is how we compare the discrepancy between the actual and also the predicted one. If the error is very big, means that your model is very poor. If your error is very small, it means that your model is very good. Make sense or not?
Yeah.
Okay.
So,
So delete. Huh?
so mean squared error is the smaller the better lah.
Yeah, the smaller the better. The square errors is the parameters for us to measure how far between the predicted and the actual. The smaller the better. The smaller it proves that the model is very accurate. It's very close to the actual data point. So in the first example, I use only one parameter. I use only one feature. I use only one feature in the first case, which is the size. So in the second example, it will scroll down. It will scroll down here. In this case, I'm going to add one more feature called what? Number of bedrooms. Okay. So in the case, you will see that it's empty. So I want you to create your own data set. You create your own data set, put your own numbers here. If you feel that two features are not important, are not sufficient, you add more features. Number of bedroom, number of bathroom, the age of the house, and so on and so forth. You add more features and you train the model using the same linear regression. So this is actually same like the previous case, totally same. But the previous case, I use only one feature, which is the house size. Okay, I build the model. In the second example here, I add more features. Same price, but I add more features. Then you will run again. Then you get the different answer. So I want you to try by adding more features. What is the so-called result? Are the number of features will affect their performance? So this one I'll let you to try now. Okay? Yeah. So I give you about 5 to 10 minutes to try to understand the overall flow, the process for the first case first. Okay? If you can understand the first case, you can try the case 1 but using 2 features, or you want to use more than 2 features also can. You treat your own features and train using linear regression. Why linear regression? Because the data is in continuous value. We use linear regression. Then I will come back for second example, which is time predictions by using what? Using already. Okay, using the label one. Okay, so I'll let you to try for the first case and also the second case. Then the class that the output that we would like to predict is like yes or no. Like in this case, we would like to build some machine learning model. Okay, where we have a text pumped into the machine learning. Then we want to predict whether it is a spam or not spam. So in this case, I give a label called handler. Okay. So this is called classification. Classify whether it's a spam or not a spam. In the previous case, we predict a continuous value. For continuous value, then we have to use linear regression, right? And then we use one of the famous techniques called so-called mean square errors to measure the difference between the actual and also a predicted value. But in this case, if we do a classification, then mean square error is not appropriate. we are not going to use MSE to measure the performance, but instead we have to use, like for example, the confusion matrix. Okay, to measure the performance. So I'm going to show you what is the confusion matrix later. So come back to this. Okay. So in this example, I would like to predict the spam or not spam email. Let me show you the data set first. So this is the data set where we have two columns. The first column indicates a label, Y. So, and then the second column here is indicate the data set. It's a string, or it can be the email content. So remember, this is supervised machine learning. We need two information, X, and we need Y here. Alright. Now, the first step, we need to import the spam text file into this Jupyter notebook first. We can use this pandas.read table. It means that we're going to pull the whole TXT file into the notebook. So the purpose that you put an encoding window 1252 because the text file is in the TXT file. So you need some encoding so that you can import successfully. And then we have a two column as I mentioned. We have a Y and X. So you just label the first column we label as label. The second column we label as text, so that we will have this table here. Okay, label we will treat it as Y, and then text here we will treat it as X later. Okay, so before we put the data into the model to learn, the first thing first you have to look at your nature for your data. So this is actually a string, and it consists a lot of noise. For example, the punctuations, maybe a stop words, some values. And others, alright? So we don't have emoji, so it's okay. But if let's say you have an emoji, you have a typo or whatever, then you have to perform a series of pre-processing steps that you learned during NLP 2 weeks ago. Like reduce the punctuations, lowercase, remove the stop word, and so on and so forth. So in this case, I will just remove the punctuation as well as to lowercase the capital. So for your case, you can perform whatever pre-processing is necessary. Alright, so in this case, I will just perform 2. If you want to perform more pre-processing, you go ahead. Okay? So after I perform the pre-processing, what to do? I need to split the data. This is the standard procedure, 80%, 20%, or 70%, 30%. It's up to you. So you can see that this is not very important. This is just to show that, how the data look like. Okay, how many data, and so on and so forth. It's not very important. The most important here is this part. It's where I'm going to split the data into 70% and 30%. If you feel that 80%, 20% is more suited to you, right, then you can just modify to 0.2 for the test side. If you feel that 70%, 30% is more suitable, then you change to 0.3. So if you mean that, I will split the two categories here. The first one is the train data, the second will be the test data. Same goes to the one. Okay, so I have a two set of data, train and test. Okay, so after you split the 70-30, just now we have a about 5,000, is it? 5,000 data. Now we split, we left 3,009 for training purpose and 1,006 for testing purpose. Okay, so now next step, features extraction. Extract the features. This is the next step. So if you still remember in the chapter number 3, NLP. So how to extract the feature for string? We apply count vectorizer. Okay? We apply count vectorizer to extract the words from a string, and then we tabulate this data. Okay, so we use this function called count vectorizer. Okay, so if you apply this count vectorizer, what you do? So this function will actually scan through all the strings or the text inside the text file and tabulate this table. Okay, let's say we have a file called promotion. Okay, and then we have an offer. So we have a serve. We have a lot of words. okay, and so and so forth. Okay, so each of these words here, we will treat it as features. This is features 1, this is features 2, feature 3, features 4, 5, and so on and so forth. So remember, machines doesn't understand the meaning, but they will treat each of the words as the features. Okay, and then we have how many so-called tags to train? About 3,000. So here we have about 3,000. Then this characterizer will start to count. Okay, for the first email, how many do we have this word inside the first email? If yes, calculate how many frequency. Maybe 2. Maybe appear 1. This is 0, 0, 0. Go to the second email. Do we have this word? Maybe none. Maybe none. Maybe we have 1, 0, 0. And so on and so forth. We will tabulate. So once we tabulate string data, together we have a label which is called Y. So let's say the first one is a spam email. The second one is not a spam email, and so on and so forth. So this table is very important for a machine to learn. The machine will start to find the pattern. Oh, if I have this kind of word promotion, if I have a word called offer, then it is a spam email. Okay, if let's say I don't have a promotion word, I don't have this offer word, I have this word called serve, then this is a spam email. And so on and so forth for the 3,000 email. So you find that you will study itself and also find the underlying pattern. So this is how machine learn. Okay, so you can see that from here, I use a technique called characterizer stop word English. It means that if I apply characterizer English, it means that for each of the emails, firstly, I will remove the stop word first. I will remove the word that's not important, and I will tokenize the string into individual tokens and also to calculate the frequency. And this one, I will use it as the features to train our model later. So I have an X, I have a Y. So then I can form this X and Y here. So this one is just to show the table form, the features and the frequency. Okay. So I'm going to use the logistic regression as I mentioned. You can use logistic regression, you can use the support vector machine line by recursive method, as long as they're used to classify the class. And then I'm going to fit, means that I'm going to train using the X and Y data, and finally I evaluate the performance using predict. I have I already built the models. I will use the remaining test data to do the prediction. Then from there I can measure the performance. Okay, so you can see the overall pipeline for either the continuous data one or the class one, class based, they are the same. You need to prepare your own data set, clean the data set. If your data set is like the value one, continuous value, then not necessarily that you need to perform the cleaning process. If let's say for a string, then you have to perform a series of cleaning so-called process, and then after that split the data, then you can start to extract the features. Extract the features, put inside the model to train. Train, then actually finally assess the model, evaluate the model. Okay. So for the step 5 here, that you will see this confusion matrix. I will not cover what is confusion matrix today. I will cover what is confusion matrix during the lecture class. So confusion matrix is one of the technique to assess the performance of supervised machine learning. Like just now, the square, the mean square errors is for continuous value. Confusion matrix is for the class-based prediction. Okay, so make sure that after you perform this evaluations, make sure that the accuracy, precision recall must be more than 75 or 80%. It means that the model is good enough. Okay, and then finally, you're done already. You already built the models. Then you can pump in the new or unseen data. Let the machine to do the prediction. So in this case, I pump in this 3 entry into a big competition to win the FA Cup final ticket. So using the logistic regression that I trained earlier on, is so that this email is actually a spam email. Okay, so that is the overall process flow for supervised machine learning. If you don't like to use logistic regression, like in this case, then you modify. You modify using what? So you can scroll down here. I provide you another algorithm called naive. I will just use this naive. We train again, recycle the X and Y data, but I change the the supervised machine learning model needs. Okay, then you get the result. Then from here you can compare what is the performance between naive Bayes and also the logistic regression. Okay, so yeah, you can go through. After that, try the exercise and the last part, machine learning and NLP exercise. Okay, yeah.